Okay, welcome to the second week of Beginners Python for Engineers. The topic of today is selecting and cleaning data. And I actually think in data analysis, the cleaning data or the figuring out what data you have is actually one of the most important parts you'll be doing. Also one of the most frustrating ones. But that's why it's so important that we get a bit more insights how to do that properly. Okay. So I would just like to say again, thank you to Aaron, Jon, Melanie, Visa, and Sek, because without them, this course wouldn't be here. And I highly appreciate their work. And I think it's important to give credit to the people who the credit belongs to. So these are the guys who contributed a lot to this. Good. Now, if you didn't do that yet, you should sign up in our Slack. You should sign up in A+. You should be aware of our My Courses page. This is also the page that every now and then sends announcements, and also of our deadlines. Good. Again, about the lecture. So last time, no one really dared to join with video. It would be very nice for me if I don't talk into the void. I mean, I will not force you to open the video, but I would highly appreciate to see some people and not to just talk into my screen here. So thanks. Hi. Nice to see that there is a person. Okay, so generally, if you have a question, just feel free to open your microphone and ask. You can also just write the questions in the chat. I will check it on a regular basis, but I will not always see it immediately. And the sessions will be recorded and put on YouTube later on, like unlisted, so no one will find you unless they have the link. Good. So again, the structure of this course, we talk about input, we talk about calculations, and we talk about output. And today we're in week 2, where it's about the input and it's about selecting and cleaning of data. And also the timeline of the course. So as a very first step, I'm going to talk a bit about what is a data frame and how does it look like, because we will be working a lot with data frames. Then we will talk about cleaning data. And last but not least, we will also be talking about how to select data. So let's start with pandas. I showed last time a few nice things we can do with pandas. And I just told you that there is this thing that is a data frame, but what is actually a data frame? And generally what you can think of if I say data frame is just like this table. Data frame is basically a table. And it's also sometimes called a two-dimensional thing. Why? Because it has 2 dimensions, like there's this dimension, the columns, and this dimension, the rows. Let's look at it again, how it looks like in the real environment of Python. So here is my notebook again. And I first want to talk about the situation without pandas. So if we don't have pandas, what one usually does to store data is a dictionary. I think you should all be familiar with dictionaries, but here's a short reminder. So for example, if I want to have a person as a dictionary, I can have keywords like first for first name, last for last name, email for email address. This is the keywords, and this is the corresponding value. So if I run this, what I get, a person looks then like this. This is dictionary. If I want to have several people in this dictionary, then what I can do is I can start a list. So the keyword stays the same. So here first, last, and email is the keyword. And I have here a list of people. I mean, now there is only one person in it, me, but I could put several ones. So this is how it looks like with this list. Important to note is that I can have as a keyword basically many things, and as a value, I can also have a list. So this is not, for example, if you think about databases, you cannot do that. You have to have single values or atomic values in everyone. But for Python, if you have a key value pair, the value can also be a list or an iterable. And now here is the thing that we would actually want to do is we now have several people in this dictionary for people. And the first is the the keyword for the first name, then the last for the last name, and then here emails. So this is how I would be doing it without pandas. Also, if you want to see it a bit nicer, there is this P print. This stands for pretty print. So if you pretty print it, then you have it nicer aligned. What you can also see here is this dictionary is actually a set. It's not like in pandas where you have a table with the number of rows and the number of columns, but it can be arranged wherever. So email can be first, or there is no order because it's just a set of key value pairs. Now, if you're interested in to know what is the type of these people, it's of course a dictionary because we did it as a dictionary. And if I want to know the email addresses, the way I would access it is I would say, okay, I want to have all the people, and the keyword is the email from this dictionary. Then I would get the list of emails. And the type of actually this is then, of course, a list. So the dictionary contains lists. It doesn't need to, it can also be single values, but the way I defined it is here is a list. And now how does this translate to pandas? So to pandas, it translates as this. So let me import this. And we saw the last time how to make a panda data frame by reading in, for example, a CSV file or an Excel file or things like that. But you can also just do your own data frame. So this you can do by defining it that way that you cast it as a data frame. It's a way you can do with pandas. And here, the nice thing is it actually has the same syntax as a dictionary. So you can give a dictionary and then make it into a data frame with pandas. So I now just did this people I defined previously as a dictionary, and I made a data frame out of it in pandas. And this is now how it looks like. And you can see that it looks already way better and fancier than what we had with the dictionary. Also here, of course, we now changed the type. So the type is now a data frame from the pandas package. And let's now see if I want to access the email addresses again. I can ask for just the email column of the data frame. And here I get this email addresses back. I also get some more information, like here are now suddenly row numbers. And now if I want to know what is the type of that, this is called series. And so there are a lot of similarities with the dictionary and the data frame, but it is not the same, as you can see, because we have way many more tools to deal with data frames. Let me go back to the slideshow. So in order that you understand the vocabulary I'm using, so this is now a data frame, how it looks like. And what I also wanted to say, whenever you want to do something with a data frame, I highly recommend to make a small data frame like I just did here with a few columns and a few rows and test your methods. Because it's usually way easier to figure out if what you're doing is working if you have a good overview of how it looks. And it's very easy to make one of these, like just take this dictionary and plug it into a data frame, and then you can try out all you're doing. So now a set, so here, these are the column names. This first, last, and email is the names of the columns. And I said before that it's two-dimensional, so we have two axes, and this is axis 1. Then what is new, what we didn't have with the dictionary, is here indices. So Panda automatically makes me indices from 0 to n, or to n-1 then. And these are called index label. I can also choose indices myself, so I don't have to rely on that, but this is what Panda does if I don't say anything else. And this here, the index is the axis 0. So there are two axes, it's axis 0 and axis 1. As we're used from Python, we always start with 0. Good, and also don't forget, like the whole thing is a data frame, and one of these columns is a series. So Pandas has basically two types that it deals with. One is a data frame and the other one is a series. And some things are done with data frames and some things are done with series. So keep in mind with what you're actually working. Now, if we have this, we also would like to access data. And we can do this in several ways. So we can do it by column. And this is very easy because this is one of the things most of the people do all the time with pandas. So you can just say, so if you defined your data frame as df, and then you can just say, okay, I want to have the data frame, the column email. Then what you will get is this. If you want to get several columns, you can give a list of the column names. Like here you can see there is a list. First and last is in there. And then you want to have the data frame with this. So this will return these two. And you can also do it by row. How you do that is you can say df I location 0. So this gives you the whole row on index 0. And if you have several rows, for example, from 0 to 2, from 0 to 2 will give you the first two columns, you get these two. I would like to warn you with this iloc. So pandas also usually warns you when you work with that. And the reason for that is that usually when you work with data, you don't want to go down to access this by index, because usually you want to have like data that fulfill certain criteria or else certain columns of it. So as soon as you go down to the indices, there's probably something you do wrong. I mean, there are situations where you need to do that because this is the way to to get exactly access to something if you know it's in this row and in this column. But be really sure to use it, that this is what you're doing is the right thing, because usually there is a nicer way to do things if you want to do general things with data. So for example, don't loop over all of these by using these indices, because this is bad practice. There are other methods by Panda to go through all the values. Then if you want to have an exact element, you can use this iloc again. And here, as you can see, we give now again 2 entries because it's 2-dimensional. So this is O2. So this is O and this is 2. And of course, this is again a bit disgusting because you have to really know where is this thing. So you have to know the location. But what you maybe want to do is like you want to have it in the first row and where whatever is in the email. So this is usually how we access things. And then there is the line is called df location and not I location. So this is how you can access elements if you need to. And again, use I location with care. Let's see again how this looks like in real life. So we have here this access data, and we still have this little email data frame. So if I just want to have the column, I can run this and I get these columns, and I also get these indices. I can say index is false, then it will not print the index with it if I really just want to have the email addresses printed out. But if you just want to have a look at it, then this is totally fine. Then here, the example, when you want to have more columns, then you give a list. Here you see again this list with the names of the columns. If I run it, you now get these 2 lists, a data frame with these. Now, if I want to have the first row, I use iloc here. And here you see in the first row, there is my name, first name, last name, email. If I want to have several rows, I get this. Here now get row 0 and row 1. So it's always 0 to 2, as we also know from the range command. This goes from 0 to n-1. So it's row 0 and row 1 here. If I want to have all, I would have to write here to 0, to 3, and I get the first 3. And again, if I just want to have one single item, I can use this E location, and I get this entry. Or I can do it with the name of the column, and this is exactly the same because this is at position 2. Now, as said before, like one of the really nice things with these data frames is it gives us a lot of more tools at hand what we can use. And one of them is, for example, this string replace. So we don't have to do something to every single item, but what we can tell pandas is to just look, take all of the row. No, I did something weird. Take all of the entries in the column email and replace the string at with IT. Let's say we want to have the robots not crawl our email addresses. So then what happens is it does this for every entry here. Now, if I look at this data frame again, you will notice that here is the @ again. So you're maybe wondering why is this here if I just replaced it? And the reason for that is that this is not mutable. So this does not replace it in the data frame itself. So if you want to have it replaced in the data frame, you actually have to reassign this. So you can say the data frame column email should now be replaced with this when I replace it. And if I run it now and I look at the DF again, you now see that this actually took place now in this data frame. And it's always important when you work with data and you manipulate it, always check if it actually happened or not. Because it happens very often that something goes wrong and you expect that you're working with something that you're actually not. So it's always a good thing to have a quick look if things went through or not. So you will see this a lot from me, that I just print the thing again to see what happened. Yeah, and now we know it changed. Another thing you can do, and you most likely have to do if you read in data from someone else, like you want to look at the columns. So there is just this DF columns will give you the columns. So you know the names, so you don't have to check them out in the file yourself. You get them here. And usually you want to have different names because whatever these people called them, you probably have a different idea behind it. So you want to have a more descriptive name. So one way to change the columns is just to reassign different names. So for example, if I now say, okay, the DF columns should be called first name, last name, email with a capital letter, and I can just assign it like that. You can also do it with a dictionary where you have the this and the new one as a value, then it will only change the ones you want to change. Let's say there are a lot of columns and you only want to change parts of them. But this you can look up in the manual. So here now I changed all of them to what I want them to be. And now you can see this takes place. That I have now new column names. Okay, let's go back to the presentation. So now, what is usually the case when we get data or when we download data somewhere? It's messy data. Of course, if we do the data ourselves, we have some handle there to decide how it looks like. But if you get it from someone, usually it's just one big mess. Also, if you combine data, there is usually a lot of things happening. And now I would like to know from you what can go wrong. Like, what are possible problems? Why do we have to clean anything? And what can be messy? And I now open the chat to see what you think. I actually wonder if you can see the chat now, because I share it on the thing, but I think sometimes Zoom blocks out its own stuff. Okay, no one an idea? So in your world, all the data you always get is perfectly fine to use. Okay, someone. Okay, so one of the problems is missing data, missing values. Yes, that can be. So sometimes we have columns that do not have an entry for every row. It can be inconsistent. So some values have comma as decimal separator, some have period. Yes, this is also something can have. Wrong data type, exactly. Also, one of the things is, what is the data type we have? Like, there are a lot of things we don't know if we just get the data from someone. Okay, that's it's already very good hints. Exactly. So what you said is all true. Let's first focus on the different data types. So you're probably aware that there is a big mess out there about dates. So there are a lot of different formats, and there are actually, most of them are still used somewhere. Yeah, you can have like this month, day, year. And for example, the 17th of February 2021 would look like that. Then there's also the other version where you first have the I mean, you have month, day, year. Oops, you have month, day, year, but you don't have the full year, like you have only 2 decimals. Or then you have this where it actually changes, where the day and the month are exchanged. So this is particularly annoying because they look basically the same. And the only way to figure this one out is if you know what's in the data, or if you're lucky enough to see that the month 12 does not exist. But otherwise, you're dependent on the data. You're not able to know unless you have additional information about the date. And then there are also all kinds of weird things, like that you also do not have leading zeros, but just like 2, or even up to names that you have the month in this abbreviation name and whatnot. Then, of course, there's a lot of languages out there, and this can lead to many problems because it gives you inconsistencies. If you have some elements you don't know, it's also sometimes not clear how to order these things in alphabetical order. So the best way is always to unify it into a way you can handle. And last but not least is numbers. So in computing, or in code, we usually use this very first version. So like there's a number, then there's a decimal point, and then the rest of it. But as someone pointed out, there could be also a comma. As far as I know, in Finland, there are commas. The first time I had to fill out a bank transfer, I was really confused. But it can get even worse. Like there are some countries that have like this upper comma for thousands, or some also have a lower, so they can even have 2 commas. And then there are other ways to write it. Like, for example, this just means K is 1,000, so you have 12,000. Or you can have this notation, the exponential. So this just means times 10 to the power of 4. So this is, by the way, always the same number in all these different formats. Then you can, of course, have a binary representation of it, or a hexadecimal one. And the important thing is really that you know which format you have, and then unify it to one. And unify it to one that's easy to get. So, but sometimes it's not clear which one it is, so figure it out and then use one you know how to use and deal with. Okay, and my watch just told me that I'm already talking since over 20 minutes. So I suggest we have a small break. And this is a slide I use very often. So I got a bit bored of it. So I thought today we try something else. So I recommend that we do this exercise 2 times for each side, 3 times. And of course, you don't have to do it. You can also just drink a bit of water, but I'm going to do that now. And the break will be as long as it takes me. And I will turn off the camera for that, so you don't have to see that. But after that, I will be back, and I guess we will be a bit better able to focus again. So see you in a few seconds. Okay, so my shoulder feels a bit better again. Let me look at you again. Okay, so I hope everyone who went down to the floor to actually do that is back. Then let's continue. So now we talked a bit about what can be the problem. And now the question is like, where do we figure out where the problem is? Like, how can we find it? So basically, where's the poop? And there is not much else you can do than to look at your data. I mean, of course, if you know where your data is from and you know these things, that you have different date times and whatnot, you maybe even know which ones you have. But if you just get data from a source, you're not totally sure, or it's not very well described. What you have to do is you have to look at the data. And there is this very important thing, df.head. It just gives you a short overview, but of course here you cannot find all the inconsistencies because it just shows you a very limited amount of. Another thing you can do is you can look at the types. And here I will soon show you how to even get better types with pandas, because then we can actually deduce some of the things from it. So let's get back to the Python notebook. So here is the same data we looked at the last time. So I read it in from this Excel sheet. It is it's called dirty data because there are some things in it that shouldn't be. As you can see here, it's in the folder original data. And usually what you should do, you should have your original data on a different place stored than the data you store that you worked with. So I usually recommend to have 3 different folders. One of them is the original data, one of them is the data you work with, and one of them is your results in the end, because you also don't want to have your working data overriding your results, which you already had. And the only way to do that is to really store it on a different spot. Okay, so we read it in now, this Excel. It's an Excel about weather data from around the world. Now let's have a first look at it. Let's see how this looks like. And you can already see here now that there are some weird things in it. For example, there's this NAT, there's this NAN, and some other things. So we already know that there is something not totally cool here. Now, one of the important things with selecting and cleaning data is what we usually want to do is to clean the data before we do anything about it. And we don't want to select the data first, but we first want to clean it, because if there is some other data that can help us to deduce how we can clean the data, for example, if there are some language incompatibilities, it's good to know where the data was taken, so we have a chance to figure out which language it was. So we don't want to remove this information yet, even if we maybe do not necessarily need it for other things. It can be helpful for the cleaning process. Also keep in mind that data you don't want to use in the end, you don't need to clean. So we don't need to do the work for things we don't want to use in the end. Okay, so now let's see, let's take a look at the types. So let's first see what the data frame, like what pandas did when we read this thing. And you can see that the pandas already assigned some dates here, types. So for example, this station, if we take a look again here, station, this is like this unique identifier for a certain weather station. This is an object in Panda. And then we can also see that the latitude and the longitude was already discovered that it's a float. So latitude, longitude from these stations are floats. And what else do we see? We can see that the snow is apparently a date time. And then we have a lot of objects. If you look at it, you would actually expect that this name, for example, is a string, because there are just names for the weather stations. But in Panda, they are objects. You should also keep in mind that when Panda reads it in, it already does something to the data. Like, so for example, this NAT or NAN, this is, I will get to it a bit closer a bit later, but Pandas figured out that this is not a proper value, so it already puts this very special value here. Yeah, so if you want to know exactly what was here, then maybe you have to check out the CSV file with the text editor to get the real original value. But now, one thing that's pretty cool that you can do with Panda is that you can use this convert data types. So what Panda does, like here, it just figured out what it is, but you can force Panda to be more more forcing on more specific types. So like if I run this types now again, so after forcing it to convert it to the most strict types, you can see that quite some of these these objects became strings. So now this helps to get more precise types from pandas. You can also see that there was still a float, 64. And one thing you can also see here, for example, it figured out that this is not a float, but it's actually an integer. With respect to space, this helps you, for example, to save space if it's not saved as floats, but as integers. But this also depends a bit on the size of your data, how much this helps. So, but to do that is actually quite convenient, because then you will get even a better handle on your data. Now, what you maybe see here is that the date we kind of would expect to be also of this date time, right? The type, because a date should be somewhat of a date. But here it just says object. Object is like the the most open type pandas has. So now, because here we see that this is an object instead of a string or a date, we think that there is something here that needs to be cleaning. And now let us take a look at these dates to figure out what's happening. So I run this. So what this does is it takes a data frame, the column date. It makes a string out of it in order to print it. And I set here index false, just so that we don't have the index left with. It's not so important. It's just a bit prettier to look at. So, and if I now have this here, so these are now all the entries we have, and I can scroll through here, then I pretty quickly see that here's something different. And here is not this very nice date format like all the others, but you can see it looks a bit different, and this is most likely a string. And this is most likely the reason that pandas couldn't do this date conversion to the type, but had to go back to say that it's an object, because it's kind of mixed things in there. Okay, so now what do we do with that? Now there is a little part that is quite complicated, because it's called regex. It's a very powerful tool, especially with Python. It's something that's totally worth to spend time on, to learn it and to use it. Unfortunately, in our course, we don't have enough time to also look at that, but this is, for me, something I want to do next year, to spend more time on regexes, because they help you a lot. So now, in this time, you can just think about it this is a tool where you can do string comparison to get out certain patterns or certain elements of a string. So what we do here, we import this regex, it's called. And here, like how you can think of this is like here, it gives what it's searching for and in which string. So for example, this here is now just a string. It's like one of the strings, how they looked like here. And now I say that I want to search for the following thing, like this means a digit. This means actually 4 digits, and this dollar means at the end of the string. So I'm looking for the last 4 digits in the string. So year at the end will be assigned the last 4 digits in this string. So as you can see, this here is the last 4 digits in this string. Then I do the same to find the month at the beginning. So I say this here is the sign for at the beginning. Then I say I search for 2 digits. Oops. So I search for 2 digits and return them. So if I print this here, what I got out of this year at the end and month at the beginning, you can see that I could extract this year at the end and the month at the beginning. Now what we want to do is we want to, of course, go through the whole column and find all the strings that are not this date time, but that are these weird strings. And we want to convert them to the proper date time type. So the way we do that is, now we get to know another concept. Oh, I just saw that there is a question. Good. I see that someone also entered that there are inconsistent values, numbers, and string literals on the same column, null, not a number, and infinitive. Yeah, we're going to talk about more of this a bit later. And now the question was, how would you know it's 9th of January or 1st of September? Yes, very valid point. I don't. And that's actually maybe one of the reasons that if you don't know which one it is, you should just throw it away. I now know it because I got this data from a weather service, and it always takes the first of month. So I can tell you that this is always the first of the month. That's why I know that these are the months and this is the day. But I only know it because I know where the data comes from, and I know because this was the format of the thing. But sometimes you just don't know, and then you have to decide what you do. Do you get rid of the data, or do you try to figure out where it comes from? And this maybe depends a bit on what you want to use the data for and how much of the data you have. Like if you have a massive amount of data, throwing away everything that doesn't fit you is totally fine because you usually still have a lot of data. But of course, if you have in total 50 entries and 10 of them are somewhat unclear, it maybe makes sense to figure out where they come from and if they are now the 1st of September or the 9th of January. But it's a very good question. Okay, so now the way we figure this one out. So first we import date time. This is so that we get to know this type. We can use this type. And now this is also a concept or a way to deal with Python, which is very useful and important. It's called enumerate. So, I mean, what we want to do is we want to go through every date in this date column and check if this date is actually a string or if it's a proper date time type. So how do we do it? Like if you just would write this code, you probably would go for something like for my date in this column data frame for date. But because we also then want to store back this this newly generated date time to its origin, we need to know like on which level it was in order to substitute it with the real one. So that's why we use this enumerate. So what this enumerate does, it just returns not only the date in this date column, but it also gives us back the iteration we're in. Like you could also just make your own counter that counts up so that you know in which row you were when you encounter the string instead of the date time. Or you can use this enumerate from Python, which returns for each time it goes through it, it returns it to you. So here I say E is like the iteration, and my date is the value of the column in this thing. And then I will ask, okay, is this a string? And if it's a string, I have to do something, because if it's a date, then I don't mind because it's already right. But here, if it's not a date, it's a string, then I have to do this conversion to make it a date time. Okay, and I also print it out for myself so that I know that I'm doing the right thing to control if it's actually working the way I want it to. Then I do this figuring out the year from the string, figuring out the month. This is what we discussed with the regex. And then I will create this new date. I make a date time out of it. I give all this information. And then here, I use exactly the thing I told you to be careful about. I use this I location to put this new date back here. And here, this is a total fine way to use it because I know exactly that it's at this position. And I only want to do it at this position. I don't do anything fishy. So let me run this. And now what you can see here is these are all these strings, and they look very similar to the ones I've seen up here. So it seems like I found the ones that were causing trouble. And also it warns me here, like sometimes Panda, in order to be fast, it produces views along the line when it calculates something. And then if you try to assign a value to it, it sometimes doesn't work because it was just a view and not a proper object, so it cannot assign it. So as I said, be careful that you actually assign it. So now let's see, did it work what we were doing? So I print it again now, just the whole column. And now you can see that there, all of it looks nice now. So we actually fixed it. So there is nothing bad left anymore. Let's go back. So we found the poop and we actually fixed it. So again, regular expressions, it's usually called regex. This is really awesome and super powerful. So I highly recommend to take a look at it. It will make your life easier. And also, at least my life, it made fuller of swear words, because sometimes it's very frustrating to find the right one, but it's really, really cool to use. Now, the next topic is also something that you brought up here. Let me quickly check on something. So there are these values, these special values. It's not a number, not a time, and none. And let me just quickly talk a bit about them, what they mean and where they come from. So not a number. If you have this in your pandas frame, data frame, then the type will be a float. Like if all the others are integers, but you have another number in there, then the whole thing will be casted as floats and not as integers. And the type is actually a numpy type. So it comes from this numpy.none. So if you want to assign it somewhere, this is where you get the type from numpy. Then not a time. So this is from the date times. So if you have a series of date times and some element that doesn't fit, then it's not a time. And this is from Panda itself. So the type is Panda not. And last but not least, there is none. None is also the same. It's basically none. It's an object, and this is from standard Python. So this is very pure Python. This is not from Pandas or NumPy, but it just comes with Python. And all of these values can be treated inside of Pandas as is NA. So is not a will include all of these. So if you ask for this, you will find all of these. Maybe one reason why they are so useful and we really, really want them is usually when you have data and then you don't have an entry, what one would do as a first thing is one would think of, okay, if there's a number, I maybe can just put 0 as this information that it's none. Or I can put minus 500,000 if all the others are integers. So I will notice that there's not a proper value. But of course, on some point, you will have a data set that has zeros in it or that has this minus values in it. And then it's super difficult to find out which one of them is actually real and which one you just wanted to use to have this information that it's not a proper thing. And also with strings, like sometimes if there are questionnaires, there is this not available or NA, or like there are all kinds of things people enter when the value is not given. And you would like to have this particular thing where you know that this was exactly this not given thing and not just a weird way of answering things. That's why it's very convenient to have these special types where you know that if they are in there, then I didn't have a value, or this is not a valid value, and it's not just a 0 which I put there to remind myself that it's not a value. So they are really convenient, and Panda has functions that deals with that. So for example, if you want to clean values and you have this not a in it, there are basically 2 ways to go. So one of the ways that you just keep the values. Panda offers this, that you say, okay, my data frame is this data frame of let's say of this this column. It's participation, I think, and not NA. Like, so not a value is basically a value. So this here just says keep all the things that have a value in this column. The other way to go is you can drop the non-values. So this you do that way, that you say the data frame, let's say in the column PRCP, where I drop the not a values. So here I keep them because I say they're not not values, and here I drop them because I say I drop all the not values. You can also use this on the whole data frame, like you don't have to restrict yourself on a column. But here, just be careful to think, like, let's say you have a incomplete data set, like you have wind and temperature and rain, and you're interested in the temperature. And some frames don't have the wind information. So if you do this df drop NA for the whole data frame, then you will get rid of all of the entries that do not have wind. But maybe they did have entries in the temperature. And if you're only interested in the temperature, there is no reason to get rid of these values that didn't have wind, but did have temperature. So that's why you then would be using only this on the column. Okay, and there's also an example in my data set. So let me have a quick sip of water. Okay, so first I told you that Panda recognizes these not values. You can just say the data frame is not a value and show it to you. Then you can see all of this data frame, and it always tells you if this is true or not. So false means there is a value, true means it's not a value. So for example, here in row 0, we don't have any snow entry. Then here, let's see what we have here on the perception. Here we now can look at all of the values in here, and here you now find this NA. So here are some values that are not here. If you want to look at it in this is not a, we can also print it like that. Then you get this false, false, false. And then on some point here you suddenly get this true. So you know that here are these non-values from pandas. Now, how do we deal now with that? So as said, we can, for example, only keep the rows where it has a number. So not a value, not a number. So this is the code. So we say the data frame is now the data frame where there is not a value in the participation. And let me print it again. So you can now see here, I now only have the ones that have a value. Okay. Now I wonder, here, yeah, in the participation, I was quickly looking at the participation attributes because they look similar. But here now I only have the data frame where each single entry has a value here. Then here we can look at it again in this version. And now, because I dropped all this NA, you cannot see any NAs here anymore. So this is always also a good quick check, because if you scroll here through, your eye is usually pretty good in spotting irregularities. But here there is no NA given anymore because I got rid of them. Good. Next thing, duplicates. Like data can often come with duplicates, and sometimes it can be that you want some duplicates. For example, if you have a database where you store things in these tables and then you want to count how many of them are there, then maybe you want to have duplicates, but in data analysis, usually duplicates is not a good thing. So let's take as an example these names of the weather stations. And because every weather station has several measurements, like we have a lot of the same name here in this column. And now what I want to do is I just want to have the station names as a list and no duplicates. So what I can do is I can define a new data frame station. And it's basically the same as taking the data frame we had, the column name, and we drop all the duplicates. So now let's see how it looks now. And now you can see we only have this station, and each entry only shows up once. We could have also done the following thing, that we say df station is df drop duplicates, the subset is equal to name. But what we get then is like we take the whole data frame and drop all the duplicates where we have duplicates in the name. So we would get rid of a lot of measurements on these stations, and just for each name of a weather station, we only keep one entry of the weather. And this is most likely not what we want, but we have the possibility to do so in case this is what we want. So let's see. We're a bit back in time. I hope I managed to finish in 1 hour. So this was the duplicates. So again, be careful if these are really duplicates, or maybe there is more information in your data frame so that you don't want to throw them away. And now the next part, or the last part for today, is how to select data. So now we talked about how to clean the data and how to have this whole thing, but we don't need all of the data. For example, in our data set now, we had a lot of snow data and others, and maybe we're just interested in the temperature. So one of the things we probably want to do is to drop columns. You also don't want to work with a huge data set if you're only interested in a part of it, because it will use space and also time to go through it. So here we can do drop columns. So the tool offered by Panda is just called .drop. Then you can give the columns as a list. And these are just all the names of the columns I want to drop. You can also do a single one, but you can do all of them in one go and just figure out all the ones you don't need. For example, these precipitation attributes or these attributes, we can just drop. Then how do we select rows? Like, of course, we could go with this selection we saw previously with this I location, but then we would need to know where is actually this data located that we want to select. But usually when you want to select rows, there are certain criteria. For example, in our weather data, one thing you maybe want to do is that you're only interested in the northern hemisphere. Like, you're not interested in the weather in the southern hemisphere, but only in the northern one. So what you then maybe want to do is that you want to say, okay, I only want to have the rows where I know that the weather station is north of the equator. So how do I do that? So this is latitude. If you don't remember your geography lessons anymore, at least I had to check it again. So I say my data set, like my data frame, I take the data frame where the following is given, where in this data frame latitude is larger than 0. So in our data, the northern hemisphere is stored with a latitude greater than 0, and the south hemisphere is stored with a latitude smaller than 0, like a minus. As you can also see here, minus 30, minus 60, here 30, 60. So if you want to have the north, we want to have all of the weather stations that have a latitude that is higher than 0. We can also say, okay, we do not only want to have only the north, but we want to have the north and the west. So then what we do is we also ask about the longitude. So first we say, okay, we only want to have the ones that have a latitude larger than 0. So this gives us the northern hemisphere. And if we now only want to have the west, we can use this logical operator and then we say the longitude also must be larger than 0. So this will select us from this data frame only the ones that have a latitude larger than 0 and the longitude larger than 0. And this is how we select these rows that fulfill these criteria. So let's have a look how this looks in the wild. So here first is dropping columns we are not interested in. So as said, this is pretty straightforward. It's just .drop. Then we can run it. Now let's take a look at it, how it looks now. And now you can see it looks way better, like it's smaller and less of this annoying not available values. Because if you remember maybe here in like these attributes, there was a lot of confusing entries like 1 to n, 3, a, n, and whatnot. And if I don't know what it is, I should take data along because I'm not going to use it because I don't even understand what it is. So it's better to get rid of it. So I drop these things and then I have a thing where I actually understand what I'm looking at. Now here we want to select rows now. And in order to do so, I first wanted to show you again, like what is in our data. So let me run this describe. And here it gives you the overview of the latitude and the longitude. And you can see in the minimum that here we have minus, because we also have some stations in the south, and we also have some stations in the east. And now I do this selecting the row according to this criteria that the latitude is larger than 0. So let me run this. Then I describe it again, my new, like I described it now as a data frame north, because I still want to use maybe all the data for also figuring out something about the south, but now I want to have a focused look on the north. So I can say, okay, give me only the ones that have a latitude larger than 0. And now if I describe it again, you can see that the minimum in latitude is now not negative anymore. And it couldn't be, right? Because I took away all the negative values. But here, this is one way to check if what I actually did was done properly. And yes, it was. And you can see here in the longitude, I still have negative values because I still have east and west, but I only have the north now. Now here again, let's do it for several ones. Like let's do the latitude and the longitude with this AND operator, the logical operator. You can do here whatever you want. You can do an or, a not, or whatever is the criteria you want to have, you can do it here. And you can run it. And now you can see that, okay, now the latitude is still all positive. And now the longitude is also positive because I chose only the ones that are positive. So what I did actually worked. Also, you can see that the count changed, right? So here, the first entry in this describe is always the count. Like how many entries do I have? And here I had 2,311. Then when I only did the north, I had 1,173. And now when I do the north and the west, I only have 111. So this is how you can quickly check if what you did makes sense. Now, let's see. Yeah. Now, last but not least is we now did some clean data, and we cleaned the data. We also chose some data. We selected data, and now we want to store it. We will learn more about the storing and the output later on. But always, if you have work in progress, it's important to also every now and then store your progress to not lose it. And there are basically two ways to do it. So one of them is the natural one you probably can think of. So you can just save it as a CSV file, because whenever we save it as a CSV file, we can read it in again and start whatever we wanted to do with the newly cleaned and selected data in the CSV file. To do that, it's pretty easy. It's like with Panda, there is this like df to CSV. So it writes this data frame to a CSV file, and then you can just give the path. Here you can see that I chose a different folder. It's called clean and specific data. Like first, it was called original data, where I have my original data. And this here is now the clean and specific data because I cleaned it and I selected things. And now there's another interesting thing you can do. This is particularly interesting if you have big data, because what you can do is you can pickle. You can pickle your data. If you know what a pickle is, it's like this people when they have food and they want to make it that it's more durable and lasts longer, they put it in vinegar and put it into these charts like pickled cucumbers or pickled onions and whatnot. And this is basically what we also want to do. We want to have our variables from Python to last longer and to be kept, so we can pickle them. And what it actually does, it's just like it stores this thing in a Python readable manner as a variable in Python. So if I pickle this data frame and I read it in later on, I immediately have this data frame again. The advantage is it's faster, and the disadvantage is of course you can only read it back in with Python. So it's not a CSV where your Excel file can open it, or you can read it with Java or whatnot, but it's Python variable, so it has to be opened back with Python. but it's also considerably faster if you have a proper sized data set. Yeah, this then actually was it. So here again, the things we looked at. Then here this thing about saving the data, like either to CSV or save it as a Python variable. And that's all for today. And if you have any questions, I'm happy to answer them. And if not, I wish you a very happy evening and enjoy the rest of your day. Okay, there seems to be a question incoming about filtering the data. You can also talk through the microphone if you don't mind. Okay, so since the coordinates are floats, can we rely that there are no rounding errors? I'm not sure I fully understand the question. So first of all, a computer has a very limited amount of spaces to store data, so there are always rounding errors. You cannot have a very precise, I mean, it's usually much more precise than, than needed, but there is always some rounding in the computer because there is a limited number of space to store stuff. But what do you mean with can we rely that there are no rounding errors? And also another answer is always you can rely as much on the data as you know about the data. Like if you collect the data, you probably know what is the errors. If someone that cares about these things did the data, they usually give you information with the data where they say something about the accuracy of the data. But often it's a it's a figuring it out yourself. If it's important that it has a certain accuracy, you probably have to read out the data and check it yourself. For example, with these names of the weather stations, you can find them and see, check the latitude and longitude. Now, does it answer your question or did you mean something else? Okay, good, good. Yeah, so are there more questions? Okay, then I wish all of you a nice evening and looking forward to see you again next week.